So yeah, my name is Dado Valentic, and I'm working as a colorist for Mytherapy. I just really wanted to maybe explain a little bit what exactly we do. What's happening currently in the film industry is that there is a great amount of development happening in the digital cinematography. This is going beyond the HD now. There are some fantastic RAW cameras available at the moment to the cinematographers, and we still have a situation where majority of film is shot on film, and there are particular scenes that are shot digitally. So what we actually have specialized in is actually matching those digital cameras to the 35mm stock and trying to kind of create consistently good look through the film. I believe that color management is a basis for any creative and technical work in terms of the color creation and control of image. What basically color management is just a way where we are able to use some physical measurements of light sources and implement them by using certain mathematical operations to kind of be able to establish where exactly we are finding ourselves in a color space. What exactly the certain kind of pixel represented or created through a CGI is going to look like, how the viewer is going to perceive that particular pixel and that color that pixel is supposed to represent. This is basically tools that we use for basically color management. It is quite simple. This is the Macbeth chart that was mentioned just earlier, and Macbeth chart is something that I personally spend a lot of time with, looking at these colors. This particular image, by the way, is something that is called perfect image. It's basically. This is a so-called delta image, which has every color represented in this image is 100% accurate. Probably not at this point, because we went through a certain conversion from a computer screen, and then probably the monitor, the projector hasn't been properly calibrated to the input from this. So I can tell you that this is not 100% the way it should look, but pretty much what we are outputting, that what this image has exactly is that every color is exactly perfectly reproduced and rendered, and we can use it to reference, or to use it as a kind of a starting point, that we know what our RGB values are, what actually has been created. I'm just going to touch on one little kind of subject of color science, which is the way how we are able to create a transformation and create a link between an RGB color, which is what your computers are creating, what you're rendering, what your game kind of engine is outputting, to the so-called LAB color space, which is effectively the ultimate kind of color space that we have, because it takes into account perception, the way how our eye is going to see the colors. And this kind of mathematical kind of principle and calculation is actually basis for all of the color management work that we do. Because this is going to change in the next 2 years. This route is not always going to stay like this. But basically what we used to do is we used to take images that were originated in a CG environment, like from visual effects companies, or images that were scanned from a film negative. And then we would apply all the necessary transformations to them, to the liking of the director and DOP. I must say this is a very actually complicated process. And a simple reason for that is that we have this kind of conversion from the kind of digital environment where we only dealing about electrons into the chemical environment, where we actually have to predict what is this really going to look like once it's on a big screen. And actually this process is fully in place, and we work with it every day. And what 3D LUT is basically just a way that allows us to transform incoming pixels into another outgoing pixel. So that means whatever comes in, we're going to be able to predict very well how this is going to be transformed on the other side. And the way how we do this is that we basically create profiles for each of the kind of items involved in the process. So basically, we would create so-called a film profile, where we would print like a sequence of images, around 1,400 frames of images, and we would measure those colors, and this would give us a representation of how this particular film is going to react to our colors that we are outputting them. So we are outputting them this similar, something similar to that Macbeth chart that you saw before, that we know exact values that we are outputting, and then we are measuring how actually film behaves to these colors. And then when we apply this 3D LUT, we are able, on our digital projector in a studio where we color correct and create a film, to actually recreate an image that it's going to be a very good representation, or almost perfect representation, of how this image is going to look like once it's been projected on the screen. And this is why color management is so important. Now, what is actually really happening with digital kind of distribution? You've mentioned, you touched the thing, oh, once we see our shots on a DVD. My first thought was, oh, that's going to be much easier because we are dealing only with digital environment. We are not converting it through some chemical process in order to come to a kind of final result. But actually, the truth is opposite. We actually have a little bit more difficult situation in a digital environment. Instead of 35 millimeter film transformation that we used to have in a film process, we have in that box actually now a compression. What we actually also found is that specifically compression that is used by games is one that is very effective for the bandwidth and the size of the files, but introduces a huge amount of distortion to the image. There is you probably, if you work in games environment, you probably have found that, once you kind of have run your kind of material through that compression, that your images look very desaturated, that black and white points have moved completely, and so on. But we have to basically be able to kind of simulate what is this compression really going to do to our image. And this is not just a color adjustment. There is a certain amount of processing we need to do to the image in order to be able to recreate that effect. Another challenge that we actually face with the digital distribution of images is the fact that there is more than one display device. Each one of these devices actually has a different response to how they're going to display this image. And so we need to actually create more than one look that's going to be able to kind of tell us what is this image going to look like. So during the color correction, we have to be able to switch and say, okay, this is what's going to look like on a plasma screen, this is what's going to look like on a computer screen, or this is what's going to look like if it's projected through some sort of home projector. So there is more than one device that we are kind of delivering to, and problem is that not every device is capable displaying all the colors that you are able to produce. So what we actually then do is we create so-called color profiles that we can also convert into display profiles that you can load onto your graphic card, so that the compositing artist that's working on a shot is able to basically see the shot with the eyes of the viewer. This is exactly what's important about it. We really want to kind of, while in production, we want to be able to kind of give people an artist control of how these images are going to look like once they are at their final destination, and not necessarily how great they're going to look inside the studio on their monitors, because that's not the environment how people are going to be able to view the images. If you want to find out a little bit more about any of that, you can go to our website, which is called mytherapy.tv.